Continuing lesson IN1 on prime factorization, we're going to look at some problems here that are not in your books. So starting with number 1, they want us to write the prime factorization of this number. So we have 90 for prime factorization. We're going to break it into its prime factors. There's several options you have for breaking 90 down into prime factors. I'm going to just go with 9 times 10. 9 times 10 equals 90. And then 9 is not prime, so we'll keep breaking it down. 9 we could break down as 3 times 3. 10 we could break down as 2 times 5. At that point, those are all prime numbers. So now for writing our prime factorization, remember this is our factor tree. Okay, we're almost done, but that's our factor tree. Our prime factorization, we're going to start with the lowest prime number we had, which was the 2. Then we've got a couple of 3's, so we could say times 3 to the second power, and then we've got a 5. So 2 times 3 to the second power times 5 would be our prime factorization. We need to verify those are all prime numbers for the bases, the 2, the 3, and the 5. And then also, if you had time, you could go and multiply those together. So 3 squared, 3 times 3 is 9. 2 times 9 is 18, and then if you work out 18 times 5, you'll get 90, which will tell us that we've got the right answer. We'll look at number 5. They want us to find the greatest common factor for these numbers. So 45 and 60, we're going to do prime factorizations is one way of doing this. So 45 is 5 times 9. Remember, if numbers end in 5 or 0, they're divisible by 5. 9 is 3 times 3. 60 different options. We could do 6 times 10. 6 is 2 times 3. 10 is 2 times 5. And then at this point, for greatest common factor, we're going to look for factors that both of these have in common. We're going to look at these circled numbers on each side of this line that I drew and see which ones match up. So as we look at these numbers, we can see that we've got a 3 in common here, set of 3's in common. We've got a set of 5's in common. At that point, all that's left really that we haven't taken yet, there's 1 3 over here, but if you'll notice over on this other side, there's not another 3 for that to match up with. So we had a set of 3's, we had a set of 5's. So for our greatest common factor, we multiply those common factors together. 3 times 5 is 15 would be our greatest common factor. And what that means is both of these numbers we should be able to divide by 15. And that's the biggest number we should be able to divide them by. Okay, so if you had time, you could test this. 45 divided by 15 would end up being 3. 60 divided by 15 would end up being 4. And if you'll notice, 3 and 4, they don't have anything in common. 4 you could break down as 2 times 2. No common factors with 3. And so that indicates that we have got the correct greatest common factor. Okay, continuing with number 7, we've got the same directions here, looking for a greatest common factor. Oh, one thing I didn't mention is when you do these, if you want to, you can try in your mind, if you want to just quickly think about what number you think they might both be divisible by as your greatest common factor, and then work it out and just make sure if it's correct or not. Okay, so 18 and 30, we're going to do our prime factorizations again. Like I said, there's different ways you can do these, but this is just a way I'm choosing to show you how to do this. So different ways to break 18 down. One option, we could do 2 times 9, and then 9 is 3 times 3. 30 we could do 3 times 10, and then 10 is 2 times 5. At this point, if you want to draw your line, remember we're looking for common factors on both sides of the line. We have to have a match on both sides of the line here. So if we look at these, there's a 2, a factor of 2 that they both have in common. There's also a factor of 3 that they both have in common. So we're going to take the 2 that they had in common, the 3 that they had in common, and then we're just going to multiply those together. So 2 times 3 is 6. So our greatest common factor is 6, which means 18 and 30 both could be divided by 6, and they would come out evenly. And like I said earlier, if you wanted to check that, you could divide both of them by 6 and then see what you get left over and make sure you don't have anything still in common. So 3 and 5, those are both prime numbers, no common factors other than 1, so we should be in good shape. The next section, they want us to use prime factorization to find the least common multiple. So if we look at number 10, least common multiple of 6 and 15, one way of doing this is to list the multiples of these numbers until we find something that matches up. So multiples, we're multiplying. So like 6 times 1 is 6, 6 times 2 is 12, and so on. Or you can think of just counting by that number. So we've got 6, 12, 18, 24, 30. Multiples of 15, since 15 ends in a 5, all the multiples of 15 are going to end in either 0 or 5. So 30 was my first one that I came to that ended in a 0 or 5. I'm going to try multiples of 15 and see what happens here. Next multiple of 15 is 30. Oh, perfect. Okay, so least common multiple of those numbers is 30. One way to think about it also with least common multiples, I mentioned the other day, if you think of these, if these were denominators in a fraction, you know, think about what would we have to get get a common denominator. Okay, and there's different things that could work. Obviously, we could just multiply 6 times 15 would be a common denominator, but it works out the least common denominator here would be 30. Okay, so again, just a different perspective, but list your multiples out and then see what's in common. Your first common multiple, your least common multiple is going to show up on those lists. Number 14, the student council was preparing for the school bake sale. The members divided each type of donated item equally on plates. Each plate contained only one type of item, and every plate had exactly the same number of items. There were no leftovers. What is the greatest number of items that could be placed on each plate? Okay, so lots of stuff going here. So each plate contained only one type of item. Every plate had exactly the same number of items, and there were no leftovers. Those are kind of the main points out of this. So if we look at this, we've got some muffins, breadsticks, and rolls. Okay, so the main things we talked about in this lesson: greatest common factor, least common multiple. This one we would need to do greatest common factor. We want to think about, you know, what's the biggest number all these could be divided by evenly. So we can split them up and have the same amount of muffins, breadsticks, and rolls on all of our plates and have nothing left over. So this one a little different is we've actually got 3 numbers. And so when we break these down, we're going to be looking for things that are in common with all 3 of them. So to break the 96 down, we've got different options. One option, if you remember, with your multiplication facts, 8 times 12. If you don't think of that, if you're having a hard time coming up with anything else, if nothing else, 96 is an even number, means it's divisible by 2. So we could do 2 times something. So if you do 96 divided by 2, if you work that out, you'll get 48. So we got 2 times 48. So the 48 we could break down as 8 times 6. And then we could continue. 8 is 2 times 4. 4 is 2 times 2. 6 is 2 times 3. Okay? Make sure you come back. Make sure you pick up all the loose pieces there and get all the stuff broken down into prime numbers all the way. So 48 different options. One option would be 8 times 6, and then 8 is 2 times 4. 4 is 2 times 2, 6 is 2 times 3. And then 84. So for the 84, if nothing else, it's an even number, so we could do 2 times 42. So 42 we could break down as 6 times 7 would be one option, or you could do 2 times 21. Different ways we could do that. 6 is 2 times 3. Okay, so the difference now is we're not just looking at 2 things, we're looking at 3 things. If it's a match, it's got to match in all 3 spots. So if we look at all these, it looks like we do have a 3 in common in all 3 places. And look around again, we've got a 2 in common. And then we keep looking, and it looks like we've actually got another 2 that would be in common as well. The 84 doesn't have much left. The only thing left with the 84 is a 7. I don't see any other 7, so that's going to do it. So we've got 2 2s and a 3. So if we multiply those together, 2 times 2 times 3, and that would be 12. If we go back to the question, make sure we answer the question. The question is, what is the greatest number of items that could have been placed on each plate? And so that would be 12. That would be correct. Okay. The other thing they could have done is they could have said, how many plates of each thing would we have also? And then we would have to divide them up. So, like I said, if you have time, it probably wouldn't be bad to just verify. So that'd be 8 plates of muffins, if you think of it that way. It'd be 4 plates of breadsticks. And it would be 7 plates of rolls, if they asked you that question. Also notice the 8, 4, and the 7, mainly because of the 7. There's nothing in common with those 3 numbers any further, so we know we've got the correct answer. Finally, if we look at number 19, we're looking at this diagram at the right for this problem. Museums Outreach Group performs shows in schools every Monday. Okay, so in schools every Monday. And public libraries every 5th day, both weekdays and weekends. If the museum did both a school show and a library show on Monday, how many days will it be until the outreach group does both shows on the same day again? Okay, so if we look at the information over here, we can see our show schedule. And that actually has more to do with number 18. Okay, so 18, you could work through that one. But 19, basically we don't really need any of that side information. So if the schools are every Monday, that would be like every 7th day. Every 7th day is going to be a Monday. Every 7 days or every 7th day. The library, it says, is every 5th day, so every 5 days. Okay, so every 7 days, every 5 days, we're trying to see when these would both happen again at the same time. So for working this out, we are going to do a least common multiple for this one. So if we list multiples of 7. Now remember, libraries every 5, so multiples of 5 are going to end in 0 or 5. So if you wanted to, you're probably good with just continuing these until you end with something that ends in a 5, just to verify it and to show our work, I guess. We can list out for the other one as well, and there you can see the 35s match up. Okay, so that means every 35 days, those things will both happen on the same day. So this gives you an idea of how to work with prime factorization, greatest common factor, and least common multiple. Have a good day.